principals, HOE, in charges, HODs, subject coordinators, KG to 8 science teachers of all branches of Aditya. It's my honor and pleasure to welcome you all to our Candid Science Orientation Program. Today, we gather here to embark on an exciting journey into the world of science guided by esteemed Cambridge curriculum. Before we are going into the session, I request you all stand for the prayer song.
வாழ்வினில் செம்மையை செய்பவள் நீயே, மாண்புகள் நீயே, என் தமிழ் தாயே. வீழ்வாரை வீழாது காப்பவள் நீயே, வீரனின் வீரமுன் வெற்றியும் நீயே. தாழ்ந்திடும் நிலையினில் உனை விடுப்பேனும், தமிழனை நாளும் தலைகுனிவேனும். சுழ்தின்பம் நல்கிடும் பைந்தமிழன்தான் தோன்றுடல் நீருயிர் நான் மறப்பேன். செந்தமிழே உயிரே நரந்தேனே, செயலினை மூச்சினை உனக்களித்தேனே. ஐந்தாயனில் ஐந்து போகும் என் வாழ்வு, நல்லினை உனக்கெனில் எனக்குந்தான். முந்தைய நாளினில் அறிவும் இல்லாது மொழித்தனன் மனிதரம் புது புனல் மீது செந்தாமரை காடு போதது போலே செழித்த என் தமிழே ஒளியே வாழி. செழித்த என் தமிழே ஒளியே வாழி. செழித்த என் தமிழே ஒளியே வாழி.
Please be seated. I take this privilege to welcome the resource person, Ms. Vaishali Gandhi, who has done her master's with a first class degree in environmental science and education and management. She has been a successful educator for more than 12 years and headed the science department in India. She has been a part of the Cambridge training team and focuses on upskilling her training skills to support teachers in making the utmost use of Cambridge resources and enhancing their pedagogy to achieve the expected outcomes. We welcome you, ma'am. I welcome our chief guest, Ms. Kaushia Banu, Cambridge coordinator. She is also going to engage our teaching empowerment session. We welcome you, ma'am. And I welcome our chief guest, Ms. S. Guru Prasad, Assistant Territory Manager, International Education, who has been a part of implementing new curriculum in our school. Welcome you, sir. And now this is the moment to honor our chief guest. I request our dignitaries to honor our Ms. Vaishali Gandhi with the memento. Please, ma'am. Go that side. Now, I request our dignitaries to honor the chief guest, Ms. Kaushia Banu. Please, ma'am. Now, I request our dignitaries to honor our Mr. Guru Prasad sir. Yes. Now we are all awaiting to engage ourselves. I welcome our chief guests, Ms. Vaishali Gandhi and Ms. Kaushia Banu, to lead the teaching empowerment session in science. Please, ma'am.
I need to move around. Yeah, I'll just do my setting up first. Okay. I mean, you'll find me moving around a lot. Okay. So make me careful. You can just tell me, okay, ma'am, just be careful. There's something around. Um, so I'm just doing the setup of my laptop. Till that time, what I want you all to do is, you have post-its on your table. The sticky notes are there on the table. Yes, you have. Okay. So, if you have any questions, I'm going to take, you would have had a look at the resources. And if you have any questions, write down your questions. Okay. And one person in the group will just kind of collect it together. Okay. And throughout the session, if you feel any of your questions have been answered, so then just keep it to the other corner of the table, indicating that it has been answered. All right? Am I audible to everyone at the back? Thank you. So I hope you got what you have to do. Yes or no? If yes, just give me a high thumbs up. I should be able to see the thumbs up. And if there's any doubts, please feel free to ask. All right? There's no right and wrong questions and no right and wrong answers also. So feel free to resolve your doubts and queries. So I'm going to give you 2 minutes. Until that time, just post or put down any questions that you might have regarding the session today. Go for it. I think we might have to dim some lights here so that it is visible what is there on the screen. Is the screen visible? People at the last. Sure? I will. So, are the questions ready? You know what? We have one more mic, right? This is working. So I'm going to keep one mic with the participants. So if you have, I'm going to keep it here. Teachers, the second mic is on this table. So if you have anything to say, come forward and take the mic. Okay. Before we start, I want a marker, whiteboard marker. Where's I want a whiteboard marker to write on the board. Okay. So I want all attention here. So when I give you this symbol, I'm going to give you count anytime when you're doing the activity. Okay. So I'm going to give you silent count. So I will just count silently, and when my fist closes, that means that time is up. Okay, and you need to put your pen, pencil, whatever you're doing down, and you should focus on me. Fine. First instructions clear? Thumbs up. Thank you. Yeah. Now let's frame some ground rules for today's session. Ground rule means what are the rules that you feel that all of us sitting in this session today must follow? What do you think those rules should be? I want each table to give me at least one rule and make sure that you're not repeating what the other tables have told me. Okay? So think of a rule that all of us should follow throughout the day today so that we have a very meaningful and a fruitful session. Fine? From which group should we begin? I think we should begin from the last ones now. What do you think should be the first rule? Come on. The last table. Okay. 30 seconds thinking time and discussion time. Only 30 seconds. So Ms. Gosse is going to be helping me today with the slides, and she's going to be the timekeeper also. So 30 seconds. Last 5, 4, 3, 2, and 1. Stop. Yes.
Phone to be on silence.
Very good one. Excellent one. The first one is the best one. Clap. Phones on silent.
Thank you.
Thank you so much. Fabulous. Yes. Yeah, you also need to be active like me, okay?
Active participation.
Very good. Active participation. Amazing. Yeah, we go on to this. That group is also participating? No. Okay.
Keen observation.
Very good. Keenly observing. Great. Yes. This group?
Interaction.
Yeah, so interaction, participation, that will be a part of participation. Yes. Okay. A little bit more about that. What about discussion? Sorry? So that will be a part, I mean, it is kind of participating only. So participating in discussions in a way. Okay. Did I give you all turn or I skipped? Yeah. Okay. Teachers, time is up. So no discussion. This is done? No. Yeah. So this group. Yeah. The ground rule.
Encourage to all teachers.
Okay. Enthusiasm. Maybe we should participate with enthusiasm, right? Yes. Very good. Taking notes. All right. Yes, this group. So how is that a ground rule? Reinforcement, who is doing and what do you mean by reinforcement? No, but we are talking about what are the rules that we should follow or all of us should follow, okay, from 11 to 4 or 5. Sorry? Okay, all right, fine. I think that is somewhere it will fit in. Okay, reinforcement is all about participating and discussing and being open minded. I would say rather than that, yeah, being open minded, right? Very good one. Excellent. That's my favorite. Okay, time management. Fabulous. Yeah, this one. Okay, focused. To remain focused. Very well said. And I would like to add one more, that being respectful. What do you mean by being respectful? Any ideas on that? Because that is again, according to me, something very, very important. Yes? Exactly. So, when I say validating others' comments, that means that when somebody is talking, whether it's me or anybody from you, we are listening. Okay, we are giving respect to the speaker by paying attention to what they are speaking. All right. And we do not talk amongst ourselves because that is showing disrespect. That means you're not listening, right? That is one aspect of being respectful. Another aspect is that we take turns in talking. At times, when a question is asked, all of us want to answer, but we are so many of us. Okay, and when you speak in chorus, none of us can understand. So we take turns in answering or responding. Likewise, when we are discussing in group, okay, we make sure that everyone contributes in our group and not that one person is dominating the discussion. That is how we show respect. And that is how, when we follow these practices, the same practices needs to be followed in our classrooms. Okay? Yeah. Anything else that anybody has in mind with regards to the session? Yes. Exactly. So when we use, generally raising hands can be done in various ways. Here we can follow raising hands approach because we are adults. Okay, but in the class, we need to slightly change this tactic. So even if the hands are raised, it is not necessary that we always give that opportunity to that student only, because that's been the norm, and we need to change that. We want that every student in our class should participate in a very, very non threatening environment. And it's our duty to have that kind of an environment in our classroom. Every student should participate and should not have that fear that, oh, what if I'm going wrong? That's okay. That's part of learning. Okay, so today we are going to practice all of those, and I want you to kind of have this, whatever we're going to do in today's session. I'm going to try to model it out. Model it out means show it to you rather than standing and talking about it. Okay, so everything that I say, when I say or do something, you have to think from the perspective of how will it look when I do something like this in my classroom. You may also have so many students in the class. How will I manage that, keeping all of these strategies, or I would say attributes, and a lot of other things in mind? So you always have to think from that perspective. How can I make this do or make this possible in my classroom? Fine? No, yes, and no. Yeah, we are not promoting any drinks, by the way. Okay? Yeah, next, please. Also, one more thing, throughout the session, throughout, we're going to be very, very actively following all of these rules at all times. Okay, so if somebody from your group kind of gets distracted, so you're going to bring that person back and make them see, oh, you know what, these are the ground rules that we have to follow, because who has made them? All of us have together made them. These are our ground rules, so we need to follow it. Okay, yeah, thank you. Next. Yeah, so the first activity, what I want you all to do is, you have been given some blank sheets of paper. You will fold them into half, all right? And each person should have that half sheet of paper. So be very, very mindful when you're tearing it. Count the number of members in your group and tear only those many sheets of paper. Sustainability, so we avoid wastage. Little things when we state and we do in our classrooms should have an impact. Okay, so avoid wastage and make as many sheets as needed only. You can make more as and when you need them. Okay, only 10 seconds for this activity. Tearing should not take more than 10 seconds. Quickly. 5, 4, 3, 2, and the last number is 0 straight away. I've skipped one. Okay, everyone should have the sheets of paper. Okay, now there's a rule of using this. This is not a sheet of paper, it's a mini whiteboard. And you know what is the rule? Whenever you use this mini whiteboard, you have to write in big font size. So, why is that? Why should you write in big, bold handwriting when you're using this mini whiteboard? I can't. I don't understand chorus language. I've never learned that in my school. Very good. Visible for us, and it should be visible to the last person sitting there. That is how your handwriting should be when you're using this is your mini whiteboard. All right, let's get started. Next. Yeah, next. Wait. Thinking time. We're doing science, right? And what is science all about? Lot of thinking, analysis, right? Okay, I'm going to give you again 30 seconds for this. I want an answer. Let me see how many scientists we have in this session. So, a man built a square house with each side facing south. A bear walked by. What color was the bear? 30 seconds. Ms. Gausia, 30 seconds starts now. You can discuss and let me know the answer. What do you think is the answer? Okay, whatever you think the answer is, write on your mini whiteboards. Write on your mini whiteboards. Write on your mini whiteboards. Whatever you think the answer is. Time's up, and I want you all to have a show of the response on your mini whiteboards. Just raise it up. Raise it up. For the others to see, not for me to see. This group is still doing it. So here you can read the answer. This group has white. This group has black as the answer. Black, 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 Brown, white, any other color? Brown, white, black. Okay. Black, black, gray. Okay. All right. I want any one person from the teachers who have written black to tell me why black. Quickly. Who had written black this group? No. Yes. Any one teacher from this group. Why black? How did you come to the answer? Yeah, it's okay. It's okay. Something you would have thought, right? Yeah, tell me.
Childhood, I saw it as black only.
Sorry, sorry.
When when I saw it was black only.
When did you see what? When and where?
Imagination.
Sorry?
Through my imagination.
Okay. All right. Okay. Yeah.
The shadow of the bear.
Okay, so you.
It's facing south.
Oh my God. Wow. Wow, that's a different thought process. Any other thought process for writing the answer as black? We've got two responses. No? Okay. So people who have written brown. Somebody wrote brown there, right? Everyone black? Who's written brown? Now they're erasing. Why? So somebody saying brown. Yes.
In books and movies, they are brown color. That's why I
Yeah,
write
that's
brown.
a good,
Ah.
good valid reason, right? Yeah, possible. Okay. Anybody else for brown? The first groups? Any other responses that you all have? That response is for white. Okay. Anybody from brown? No. So we go for white. What's the reason?
Because the south side is the ice mountains, isn't it?
South may you have ice mountain. Which part of south has ice mountain?
Polar bear, I thought it.
Uh-huh. Okay. Yes, fine. That's correct.
That's only.
Yeah, so okay, so that's your response. So she's saying that okay, in south, the polar areas have a lot of ice, so the bear is white. Anybody else for the? I think you all had written no gray. Yeah, I'm coming there. Anybody else for gray? What's the response? It's fine. Maybe you can say it's my favorite color, and I want the bear to be gray.
No, ma'am. You said it's facing the
Okay.
south side, so the shadow falls on the bed. It become gray, no?
Okay.
That's what.
Gray, black. The shadow is gray or black. What is light in black? Yeah, it is like penumbra and umbra then. Okay, now I'll come to the grey ones. I want one reason why grey.
It's a natural color of the gray.
Okay.
So gray.
Okay. So natural color of their bear is grey. That is why grey. All right. Yes, you want to say something?
Um, White I wrote. I don't have a solid answer for this, but anyway, south, north, some hemisphere, something I thought, and logically I thought a color, a shade, something I don't know exactly, but I guess it is white because polar bear. Polar bear, I thought.
Okay. Cool. Nice. Okay. You have something to add, ma'am?
No, sir. No, ma'am. White, ma'am.
Achha, yours
Because
also.
yes, ma'am. Because it's facing is south side. No, ma'am. Beer is coming at the north side, opposite pole reactions. That's why I said white color.
Okay, fine, fair enough, fair enough. Okay, so all of us have our own justifications and reasoning. That is what science is all about, okay? So before even moving on to the correct answer, this is the first thing that you teach your students. Okay, with science as a subject, you are developing lot of reasoning skills. As science, we believe in evidence. Okay, whatever your answers were. So my next step would be go and find out if your answer is right. And how will you do that? That's again your choice. You may go on the internet, you research, you read about it, go and use encyclopedias. All right. So that is how building up of knowledge should be, rather than just giving the straight answer. But I'll give you the answer here. The answer was white. Okay. Yeah, so all the ones who have given correct, very, very well done. And you should clap yourself because you were also able to justify your response, which is more important than reaching to the right answer. You should be aware, and you have to make your students aware about their own thinking processes. That is more important. Okay, so develop that thinking, give opportunities for them to speak out, reason it out, justify their answers. Very important. Okay, sorry. Yeah, so a man built a square house with each side facing north. Okay, wait, I'm not done as yet. Read the most important sentence is with each side facing south. So I am here, okay, and all my sides are facing south. So where am I standing? Exactly, who said that? I'm at the north pole. That is why each this is a very imaginary made up thing. Okay, this is not in real, because having a square house at the north pole, so it's just like all the sides are facing south, so the house is at the north pole, and in the north polar region you find polar bear, right? It's a frigid zone, it's covered with ice, so there you find polar bear which are white in color, and that is why the answer is white. Okay, so it is about logical thinking. It is not always that the students have to memorize things from the textbook. So giving puzzles and riddles like this will extend their thinking, and they should be able to connect what they are learning from the book and how is it applied in the day to day life. How can they make connections, and how can they think logically and give reasoning for their responses. Okay, yeah, next. Now, I think we move on. There are too many. There are too many. Wait. That's the objectives of today's session. Okay, but you have to fill in the objectives. That is why those blank spaces. So this is what is the intention or objectives for today's session. Just think about it, what should come in the place of the blank spaces. So we will be learning about the dash and dash approaches recommended in the framework, and it is embedded in the resources that you have or you have been using or will be using. What is the dash and dash approaches that you'll find in the resources? Wait. You will use your mini whiteboards to write your answers. And I'm again going to give you only 10 seconds. Gausia, only 10. On your mini whiteboards right now, the first sentence, the first statements. What do you think? Which approaches are we talking about? Time up. Anybody with the answer? Can I have a show of the mini whiteboards? Okay, I can see one. What do you think? What have you written? Learner centered. Is it fitting the statement? The learner centered approach and dash approach. So think about it. Is it fitting into the statement? Think about that. And what? There are two blanks. There are two empty blanks. That is one blank. What about the second one? Science and arts approaches? Maybe. Practical and, so scientific and practical, you're saying. What? See if it fits the blank in the statement. Okay, scientific and project. Anything else? Okay, scientific inquiry and flipped approach. These are all different approaches. Wow, I'm glad. Sorry? STEM and STEAM. Okay. Innovative. Okay. Anything else? Scientific and inquiry. Okay. Technological approach. All approaches are coming out. Okay. Which other approaches are you aware of? Teaching approaches. Teaching and learning. Bingo. Yes. So the teaching and learning approaches, and whatever approaches you all told me will fit into the teaching and learning approaches. Okay, the practical approach, the project approach, the STEM and STEAM, the arts, everything fits into the teaching and learning approaches. Those are the teaching and learning approaches. So well done. Okay, next. The PLS. PLS is the primary, lower secondary. That is how we use the term. Okay, the primary is primary, lower secondary is the middle school. So the PLS science course components. So by the end of this session, teachers will know the PLS science course components and how they dash and dash together. 10 seconds. Your time starts now. Before even you can click now. I think the answer. Oh, everything is coming together. Oh, I'm sorry. I thought the first one will come. Never mind. Yeah. Thank you for that. Yeah. So link and work together. And how lesson planning is. What is the last one now? You would have read now. How lesson planning is dashed by or in the teacher's resource. Framed. Okay. Quickly, the last word now. No thinking time. Done. Okay. Essential. Essential. Anything from this group? The right answer is next. Supported. Okay, so the resources that you're using has a very important component, that is the teacher's resource. And we will explore how that teacher's resource is going to be very, very useful for you in planning the lesson and executing it next. Okay, very important slide. Now, at any point of time during the session, when you come across this slide, it is meant for you, as I mentioned right in the beginning, that it gives you some pause time, thinking pause time. It is very, very important as teachers and for students as well. So, whenever you teach certain things, you should give them thinking time to assimilate the new knowledge. Okay, so this is that time. So, it is called as the reflection time or section reflection. So, whenever one part is over, you will get this thinking time to note down your understanding. You may note it down, or you may want to talk it with your colleagues here and discuss what are the learnings, what are the new things that I have learned. And it's not only about learning and keeping it here. There's no point keeping it here unless and until you execute those. Okay, so you will also think from the perspective of how that new learning is going to affect the way you plan your lessons. Okay, how will that new planning will affect the students learning? What am I expecting to see in my students because of something new that I have tried with them? So that clarity has to be there. So ultimately, this whole session that we're having today, what do you think? Who is this for? Who or for whom is this session for? Exactly. How can we better the outcomes of the learners? It is when we undergo professional development, when we keep on improving our teaching and learning practices so that we can give best to our learners and help them achieve the goal. Okay? So it is always the student who is in the center. Always. So there's no point in attending any sessions if you don't implement it. And I'm not saying that you can implement everything that you've learned from a session, but start with something small, but start. Okay? Always have some takeaways in your notes, something that you can execute it immediately. So you should have three columns: something that you can execute immediately, something that you may want to read upon more and find about more about that thing, and you may execute it maybe 2 3 months later, and something that you may execute 6 months later. So you should have these three categories for any session you're attending. Only then it's a very fruitful and meaningful session for you as well as for the learners. Yeah. uh Wait, let me see. So we have extracts and we have handouts, no? Just okay. On each table, you know what? You should have extracts and handouts both. Wait. Extracts and handout both, so that here here also they don't have any handouts. So you can share it, okay? Any table who has got only handouts, you have got only handouts. So you can give me, I think, two extracts you'll need. Give me two handouts and take two extracts. I'll give you extracts. Here, take. Extracts. Anyone needs extracts on their tables? You all have extracts? Everyone, every table has extracts. See that you all have 2 3 handouts as well. So I'll keep that. Okay. Okay, I'll now tell you. Move to the next slide, Gosia. This is the extract. Just let me see the handouts, please. Yeah. Okay. Everyone has handouts. Just give me a thumbs up. Thank you. Now, in your handouts, what I want you all to do is I'm going to give you 3 minutes for this activity. From page number 3 to page number 5. I want you to read and circle important words. Whatever word you feel is important, just circle those words. 3 minutes. I think 2 minutes is also sufficient. No, I'll give you 3 minutes. What's your 3 minutes time, please? So from page number 3 to page number 5, lower secondary also the same page. I'm talking about the handout teachers, okay? Please look at the handout. Start reading from page number 3, 3 to page number 5. Okay, and circle the most important words according to you or what you feel is very, very important. 3 minutes silent reading time. Yeah, 3 to 5. Huh. Just circle the most important words. Do they have to? Time up. All pens down. Hands on the head. All hands on the head. Hands on the head. All hands on the head. Both hands on the head. Both. Both hands on the head. Yes. Thank you. Hands down and pens down. Okay. This is again one strategy to kind of catch your students' attention and when you want them to kind of move on. Okay. See, everything needs to be time bound, otherwise, we cannot achieve what we are set out to achieve. So, as I said, I'm just reiterating again every small things that we are doing here. You just have to think what will work for me. Okay. And you have to take it from that and start implementing it. Okay. Now, each group. Now, what did we just do here? I gave you some silent reading time, okay, to understand what the curriculum looks like. So, the books that you're going to use, okay, on what framework are those books based on? What is the bigger idea and the aim of that curriculum? What you'll find in the books, okay, and what are we trying to achieve in our learners? So the objective is to understand the curriculum, okay, to understand the framework on which the resources are based on. Okay, so I want each group to now give me whatever you've understood of this reading. Okay, what are the key words aligned to when we just circled it? What do you think those key words are? What do they stand for? No, just tell me. I just told you to underline or circle the keywords. But what are those keywords? What do they signify or what do they imply? Anybody? What are those, but sorry? Exactly. Okay? Those are the clear objectives of the curriculum. All right? Now, we come to the words. What are the objectives of the curriculum? Yes, this group. One word from this group. And you'll not repeat the words that have been already said or told.
Practical skill, scientific thinking.
Thank you. Practical skill and scientific thinking. Please focus on the terms. Practicals we're all aware of. Okay, how many of you are primary teachers? Just show me your hands up. Primary teachers. Great. Now, how many of you primary teachers conduct practicals with students? Raise your hands. You conduct practicals with your primary students? Not in the lab. Outside? Okay. Investigations and everything conducted with primary students? How easy or difficult do you think it is? Very difficult. Right. This is what I get to hear. So we're going to also explore how things can be made easy. And when we talk about scientific thinking and practical skill, it should start right from the primary stage. Okay. I have taken my grade 1 students also to the lab. So it is nothing like I will not show them the chemical reaction and all of that. I'll just show them what they have to see in their curriculum. But yes, I have taken them to the lab so that they start to get a feel of how you need to behave in a lab. What does a scientific lab looks like? Okay, what is the decorum that they need to follow? What are the things that they find in the lab, and why are those things kept like that? What are the safety precautions? So you start right from the beginning. Okay. So yeah, you can start practical skills right from the primary, and that is what I would always advocate. Yeah. So second, so that was the first very important word. All of us know when we talk about science is a very, very hands-on subject, and we want to develop practical skills in science. Okay, that's a very important objective. Yes, this group. Somebody else will answer. Everyone has to answer in my session. Let her. Yes.
Developing lifelong curiosity.
Very good. So, developing curiosity, very, very important aim or objective of any curriculum. Okay. So, curiosity is the key to get your students interested. So, you need to use your subject to develop curiosity. Very well said. Communication skill. Wow. Very, very important in today's world. Okay, even if I'm teaching maths, even if I'm teaching science, English, we all know languages is all about communication. But other than languages, in all other subjects, we need to focus on language of the subject. Okay, when we say communication skill in any other subject other than science, we mean that the student should be able to use the vocabulary of the subject. I should be able to explain my thought process, my ideas to anybody, okay, using the correct terms and vocabulary of that subject. That is communication. So I should have clear organization of thoughts. I should have clear vocabulary, correct vocabulary, and I should be able to share my ideas, share my responses, share my findings, my records, my observations to anybody else. That is what communication is all about. So it is very, very important that we allow those opportunities where learners talk more than what we talk. Very important. Yeah, that's done. This group is done, right? Yeah.
Awareness of science.
Yes. So awareness of science means, yeah, sustainability is again very, very important aspect, or I would say it's uh, a default product of science. And I would encourage teachers to follow the decorum of today's session and not talk amongst each other and be respectful to the speaker, please. Okay, if you have anything to talk which is very important other than what is happening in the session, you may just go in some corner, talk, and then come back, because it is very distracting and disturbing. Okay, yeah, where was I? Sustainability. Yeah, what else? Investigation, very, very important. As I was saying, that science is only not about doing things in the lab, but small investigations that can happen without any expensive chemicals and any expensive equipments and tools. Okay, investigation is all about that, what the child can do by himself or herself with very simple things found around in the classroom or at home, to seek answers to their own questions. Okay? Yes, this group.
Holistic approach.
What do you mean by that?
Three domains.
Yeah.
Learners are learn three domains.
Speak in the mic, please.
Learners are learn three domains: cognitive, affective, psychomotor.
Perfect. Perfect. So, holistic education, that means you need to touch upon head, okay, heart, and hand. So, whenever you're teaching any subject, keep these three domains in mind when you're planning your lessons. Okay? Yeah. This group is done. Yes.
Working collaboratively with others.
Very good. That's a very, very important skill in today's world. Collaboration. Okay, nothing works in isolation today. The streams have also collaborated. We have so many streams: biochemical engineering, right? So bio with chem and then engineering coming into picture. We have finance engineering. Are you understanding? So the world today is all transcending barriers and it is crossing all boundaries. So we need to teach our students to think that way and not confine them within the boundaries of the subject. Let them connect to what is happening around them. So if somebody is giving you very, very, I would say abstract response, don't just shun them down. What foolish or what nonsense is this? You don't know what's the reality tomorrow. An abstract idea of yesterday is a reality today. So give them that opportunity to imagine. Okay? have that idea creation. Let them create their own ideas, however impossible it might seem. But that's very important for innovative thinking and creative thinking. Yes.
Create future scientification skills.
Absolutely. Okay, so in your resources, you'll find sections that goes by the heading Think Like a Scientist. So when we have those sections in the book which says Think Like a Scientist, we want our students to develop those skills of how a scientist would work. How would a scientist work? Can anyone tell me? There is a problem, or there is an idea, or there is a statement, there is a prediction, whatever, a hypothesis. Then what will the scientist do? Research from the basic level, then to find solution, what will the scientist do? Testing. Yeah, observing, recording, trial, error, okay, and then seeing, inferring, and seeing if the inferring and the conclusion matches with the hypothesis. If not, again find out what exactly went wrong, how to improve, what to improve, again do the trial, okay, if not working. So it never happens that you'll get resolution at one go. Scientists keep on working and working till the time they reach to the resolution. So, investigation is that aspect where you allow your students to do that trial and error. So, you start with a prediction, or you allow your students to have or create that hypothesis. Now, for lower students, hypothesis is a big word. But what do you think? What is the color of the sky? Simple. Okay, so the child, whatever the child has seen, or most of them will say blue, but how will you find out, or what evidence can you give me to prove that sky is blue? We always stop when the student gives us the answer, "Oh, the sky is blue." Wonderful, right? Is that scientific thinking? So you need to go beyond. Can you give me evidence to show or to prove that what you said is correct? That is what think like a scientist mean. So the child may go interview a scientist or read in books, find out information about it, and come back to you. So I'm just giving you an example from a very basic perspective. But as and when you teach higher grades, you have to think from their age appropriateness and allow them, okay, to find or seek ways to reach to the answers. It's not about the answers, but how to reach to the answers. What are the ways that allows you to reach to an appropriate response? That's what knowledge is all about. Okay, this group is done. Yeah, this group is done. Yeah.
Global awareness.
Very good. Amazing. Right. We talked about sustainability. So when we talk about science, we start from something as simple as what's there around in our classroom. So we start from a very, very, I would say, local context to things around them. We try to see how it works in our country at the national level and how it works at the global level. Okay, water scarcity is a problem throughout. Okay, hunger is a problem throughout. COVID was a global problem. Okay, it started as local and then it spread. We got to know that it's not only our country but it is spreading across. And how did we reach to a solution? So there were so many collaborations that were happening amongst countries. Data was being shared. Based on the data, a lot of research was happening. So that is how you need to connect and bring those aspects from local, take them to national and global level. So it has your education, your system, whatever we teach, you need to extend it from our local to national to global. Okay? Yeah. Thank you so much for that. So that is what a curriculum entitles. And when you see the books, okay, whatever you have said or whatever you have shared, whenever we see the resources, you have to see that, okay, are we kind of implementing all those things in the resources? Okay, the holistic education, the scientific approach, the practical skills, are they there in the resources? Because only if they are there, then only you can implement it in the classroom. Okay, yes, next. I think I'll give them, where's it, ma'am? 5 minutes. Okay, so uh, this is what curriculum was all about. And our curriculum is designed, okay, to achieve the objectives that you all just shared. You'll find all of these aspects in the books, your learners books, that is the textbooks. Are you using the workbook as well? You have the workbook? Okay. Okay, but you can use it for your reference. Okay, okay, fine. Yes. So, but the learner's book, the textbook is there for everyone. Okay, okay, fine. So, with all the attributes or the objectives that you shared, what we are trying to achieve is this learner centered approach. Okay, so at all points of time, as a teacher, I should know how much should I be talking and how much I want my students to take the responsibility of their own learning. So I did not give you the answer about, okay, the curriculum has so many things. Who gave me the answer? All of you collaboratively. And when each person gave, the others also learned from each other. Okay, so we are trying to inculcate and uh, make the students achieve these attributes. And what are these attributes? We want our learners to be confident. Confidence is not only about standing here and speaking. Yes, that is confidence in your communication skills, your oracy. But we want our students to be confident about their knowledge of science. Okay, they should be able to see how science is seen around them, how phenomena work, what are the explanations. They should be able to make connections, so that will give them that confidence. We want our learners to be responsible. Somebody said sustainability. So we practice sustainability. We talk about it not when the chapter comes, but whenever we get that slightest of opportunity, we make use of it. So when I gave you those mini whiteboards, I told them that we are using a half a sheet of paper to sink in that value of sustainability. Okay, so it is not something to be dealt separately, but yes, as and when you get that opportunity, just kind of strike it at the right time. You have to make them responsible of the knowledge that they have and what they do with that knowledge. Can they come up with a solution? They can start with something that they see around them. Okay, that is what responsible behavior is all about. Reflective. What do you mean by reflective? Yes, you have to have awareness. Okay, so you have to give opportunities where the learners can think about their own learning process. How are they learning? Okay, what are they learning? How will they know that they've learned something? And what will they do with the thing that they've learned? You are teaching them, they are learning, writing the test, over, out, got marks, forgotten. No. Okay, knowledge is something that needs to be assimilated. We're talking about knowledge and we're not talking about hardcore memorization of facts. Okay, so knowledge is something that needs to be internalized, and the learners, your students, need to think about how are they learning, what are they learning about it, and how does it affect them. Only when this is answered they will be interested in learning. Otherwise it is useless. In fact, I know, I have been facing this as a parent. My son, I mean, he's amazing in maths. Okay, but he scores very well in maths. That is also a fact. But he tells me, see, I'm not going to take engineering. So why should I learn this trigonometry? I don't find this use anywhere. It is useless. Because the teachers have not taught how is it relevant in real life. Whatever topics we have, teachers, it has a great relevance. Okay, without relevance, we are not learning anything. So they lose interest when they don't find that connection. So give that. And science is a very, very practical subject. You see around it. It's in you, around you, and out everywhere. So point that thing out in them. Make it visible to them. And that is when they see it, they want to learn it more. Okay? So make them reflective. Innovative, we've already discussed a lot about giving them that opportunities to kind of think out of the box. Let them explore and learn things. So learning should be more by self-discovery and exploratory methods. Engage, of course, it depends on all how we execute the lesson and how engaged we can keep them so that they're interested in our subject. Okay, next. Yeah, I think 5 minutes. It's in my watch, 5 minutes to 12. So that is all about the curriculum. Okay. We will just have a 5 minute tea break, but none of you are going to go out. So this is a washroom break. If you want to go to the washroom and come back, fine. And the tea is going to be served here in this room. All right. 5 minutes. Yeah, yeah, no problem, no problem. Sure, sure, sure. You want? Everyone back? A lot of members missing. So I'm just going to wait for another minute and then we start. So please settle down. And teachers, at any point of time, if you have questions, please do not hesitate in asking. And you know what? I can see a lot of clutter on the table. For this section, I want the handout and the extract to be kept on the table. The other things, just push it a little aside so that you have space to write and do your stuff. We will be needing the handout and the extract for this session. Declutter your table. This is what we also tell our learners and our students. Be organized. Things that are not needed can be kept aside. Okay, till the time everyone is coming. So far, we've talked about the curriculum, we've talked about the approach. What do you think? Does it have any relevance or I would say connection to what NEP and NCF has told us to do? Or is it something very different that I've been talking about since morning? What does NCF tells us about science curriculum, about teaching at the preparatory stage, the middle school stage? As science teachers, what do you think our role is? How should we be teaching science? Is it something different than what we've discussed? How many of you have read NCF? Wow. You know what? Make it a point. That's a wonderful document. Let me tell you that. Okay, and whatever I've been talking about since morning, your NEP and your NCF guides you into teaching science in this fashion. They don't want didactic teaching. Okay, they want the students to turn into explorers, and they want the students to discover things for themselves. And science is all about bringing everyday things in the classroom. Alright, so I think science is something that you can make it very, very real for them. You know, I'll just give you an example. I think we're still less on one or two teachers here and there. I'll just give you an example. Like when I was teaching states of matter, you know what? Every day, students must be seeing tea boiling, vapors, and everything at their home or when they're coming somewhere. I actually took them to the lab. The only thing I showed them was I just heated water on a beaker. I covered it with the lid and I just told them to note down their observations. From where did this water come on the inside of the lid? And that was a big reveal for them. It was very interesting for them to go to the lab and explore things. Okay, and after we kind of had a discussion about their observations and how to record things and stuff, then they said, ma'am, you know what, I see my mother doing that when she prepares tea. I said, wow, that's great. Where else do you see that condensation happening? Okay, so you just help them connect the dots and they will share a variety of experiences with you. Likewise, I started condensation with a simple thing. I just told a student to go out, and we had a cooler. We have a cooler in the school. I just told that child, go and fill your bottle with cold water and come back. Okay, I took the bottle, I kept it on the table. What do you think would you see around the bottle? Correct? Water droplets. Is this something new? They must be filling it every day. They must be drinking it every day. I just asked them one question. Okay. um Suman, you filled water inside the bottle only, no? Is your water bottle broken or something? From where is the water coming outside the bottle? And she was like, my bottle was okay, ma'am. I just drank it. I don't know from where the water is coming. He said, are there any holes or something on your bottles? She says like, no, ma'am. And everyone started wondering. This is not something new. They see it, but they don't observe it. And that is where we as teachers make a difference. Okay. And that is how I started condensation. With that inquiry question, okay, they had to write down their own answers. From where do they think the water has come out of the bottle? The bottle is fine. The lid is closed tightly. So how do you get water outside when it is filled inside? And that is how that whole cycle started. And we found the answers. Then I took them to the lab. See what has happened. So hot water vapor touching the cold surface, the change in the state of matter, and they learned about condensation. And they came up with a lot of examples that, you know what, in winter season, ma'am, the front mirror of the car was filled with water droplets. Then some students came up with, I had gone to that place and I saw water on the leaves. So when you start making them see things that is just around them, nothing new, nothing magical or nothing, great, everyday things, make them observant, make them or make topics relatable to them. They will start connecting, they will start sharing their experiences like anything. So you're making the learning meaningful to them, that we see and do such kind of things every day in our life without even being aware of it. So you're making them aware. I think in the beginning somebody has said that, making aware. Okay, so you make them aware about where to see what you're teaching, where to find it, how to make those connections. Okay, yeah, we move on. So in the books that we're using, the science has been divided into what we call it as strands. Okay, so we have four content strands. Okay, so we divide the subject matter into three types of strand. One is the content strand, one is the skill strand, and the third one is the context strand. Okay, so what you see here is all your topics are divided into these four contents. We all know science is all made up of biochem, physics, and we have separated earth and space. Why? Because of the importance that it has in today's world. We know the astronomical advances, we know how things are working in the astrophysics, area and field. Every country wants to land somewhere or the other. We have sent our Mars rover. So space exploration has become one of the most important subject and area of knowledge. That is why we have separated this as a separate strand. Okay, and we talk about earth and space here. This strand, if you look at the diagram, observe the visual illustration very, very clearly. Okay, you see that the content strands, how it is extending. I would want your response on that. So observe the visual very closely and just tell me how all of these things are connected, or what it means to you. What is your understanding of this illustration? Yes, everything is rooted in science. So these are your content strand, this is the skill strand. Okay, when I said we want our students to be like a scientist, think like a scientist, work like a scientist, have scientific skills, practical skills of observation, recording, doing things by themselves. Okay, identifying a pattern, collecting a data, okay, doing surveys, finding information, research, all that will come in thinking and working scientifically. Okay, skill strand. And context, I just gave you an example of context. How is science relevant to them? Why is it important to them? Why should students learn science? Why should I learn science and why should I teach science to students? So you have to make it relevant. Okay, how is it applied in daily life? Okay, any response with respect to why the diagram is like this? What does it mean? How are the strands related to each other? Any thoughts on that? Does it mean something? I could have drawn another way also, no? Okay, that's a good one. Any other thoughts? Anybody? Okay, yeah, great. Any other ideas? Think. Teachers, think hard, think deeper, dig deeper. Wow, that's great. Okay. Anything that you have to share, ma'am? You want to share? Okay. Okay. Okay, that's a good thought. Come on, teachers. I can see only one person answering. Why is that? I said in the beginning, there's no right and right or wrong answer. It is just the perspective that matters. What do you think about it? Yes, miss. What do you think?
Biology, chemistry, physics, and earth science, they are the broad branches of science. That's why we can see the arrows are moving, like they are getting broader. Initially they were narrow, close. And in initial classes we learn science as a one subject, but as we move forward it has a broad spectrum, so we learn it differently.
Wow, that's a good thought again. Very good. See, you have thoughts. So just put it out. Wait. You wait. Yes, this group. What do you have to say? Yes. Foundation. Correct. Means developing. So these subjects are getting developed over a period of time. Great. What else? Last group. Any ideas on that? I'm going to force now. Come on.
Understanding and investigation.
Understanding and investigation. Okay. Fair enough. Okay.
One concept we use in 4 ways.
Okay. One concept we use in 3 and 4 ways. All right. Any other thought process? Ma'am in grey, sorry.
Science is life oriented, so that's why I linked to four parts.
Okay.
Integrated course.
Okay, great. See, I don't have to force you. You're all teachers, yeah? Come on. All right. So, yes, all of you are correct. What you mentioned, all right. So, when I say content strand, skill strand, and context strand, okay, we don't teach anything in isolation. So, we use the skills to reinforce the content or to help student have better understanding of the concepts in the content. Okay, so skills or investigations or experiments are part of your daily teaching. It is not something that you have to teach as a separate, today is the practical day. No, it goes hand in hand whenever you're teaching anything. And likewise, your science in context also. So when you see, this is the bigger, the entire science curriculum. Okay, and as you said that, okay, it gets broader as you teach from the lower grade to higher grade. It has its own streams which gets, diversified. And if you see TWS, it is, as she rightly said, it is embedded between or within all the four content strands. So it is not something that you teach separately. It is a part and parcel of your daily teaching. So as I gave you an example of condensation, condensation is a concept. But I use the skill of investigation and inquiry, made them record the observation, okay? And I taught my content of concept condensation. So it is not separate. It is the way you teach. Okay, and likewise science in context, it's a part of your daily integration in the classroom. That okay, when we boil tea, coffee, we cover it and there is, the bubbles settling in. So you bring the context. Yes, go. So where will you find, somebody said project based teaching, and hence I'm making this very very clear. Okay, in your books you'll find projects at regular intervals. Also in the teacher's resource, you'll find the detailed information, instruction and guidance with respect to the projects. Now a lot of times, okay, can you give me one example of projects that you would have given so far? All of us as teachers, we would have given that, okay, make this and come, like make a model of digestive system and come. I'm giving you one example. Can you all give me one or two examples of projects that you would have given in your class?
3D model of skeleton.
3D model of skeleton.
Model of plant cell and animal cell.
Yeah, favorite. Model of plant cell, animal cell. Anything from here? Anything other than model now? Yeah. Seed germination. Very good. So that is other than model. So germination experiments. Anything else that you would have given? So what about it?
You have to
Dissect.
the flower and what is the stain.
Yeah,
That's what.
stigma, ovary, ovule. Yeah. So dissection. Okay. So you have given that as an investigation, as a project. Any other ideas or examples that you can share? But they can't do it at home. So I said you have given it as a project. Okay. Things we get from trees. So it's a kind of a research based, or with the help of the parent, that they might do. Okay. Now think about all the projects that you've given or that your friends have shared so far. What is new in that? What is the child learning new in that? What new information or what skill development is happening through that project? No, what? Which skill? Just make 1 minute. I am making a model of an animal cell or a plant cell. Okay. We talked about scientific skill. What are scientific skills? What are scientific skills? Marker. I want that to be very, very clear. When we talk about scientific skills, what skills are we talking about? Very good. Observation. Then research. What else? Classifying. Okay. Creativity. Analysis. Learning is a skill. Demonstration means doing what exactly? Handling. Demonstration means I should be able to handle equipment. Okay. Demonstration means what exactly am I doing? I should be able to plan an experiment or investigation. Demonstration means what? Measurement. I should be able to measure correctly. Yes. So working with data, it can be collection of data, or it can be interpretation of data, or it can be what? Plotting of data. I need to select. I have data. What do I do with that data? Okay. Do I plot the data in the form of graph or any other statistical methods? Should I interpret the data? It depends on what data am I exactly getting. Any other skills? So these are scientific skills that I'm talking about. So the model, let us come back to the model now. The project that you've been talking about. Do you think any of the skills are getting developed through those models? Which skill? If I'm just making a plant cell, which skill is getting developed? What observe? You have already taught them that these are the cell organelles. What are they applying there? They are just copying, they are just opening the YouTube channel. Okay, they are following the instruction and they are making that model. What new information have they collected? What new skill have they developed? Or what scientific skills are being developed with that model making? Is it extending their thinking? Is it making them think that okay, this is something challenging and how do I do it? Or is it helping them in making some decision? What? Which skill are we talking about? Yeah? What are they thinking critically about when I'm making a model of a plant cell? What question am I answering there? What is the problem that I'm resolving there? Yeah, maybe that can be taken into consideration. But is it something really great? Does that require critical thinking? Think about it, okay? So, why I'm telling you this is I'm giving you this time to reflect on the kind of projects that you've been giving and the projects that we have here, okay? It talks about everything about the curriculum. So it brings the relevance, first of all. There is an objective you'll find in the teacher's resource. Anything that you do in the class should have a very clear objective. First thing, you should have a clear objective about it. And then you should let the learners know what exactly is the objective behind doing it. Why should I do the same thing which hundreds of people have done before me? All right. So when you look at the project which is given here, it brings how science is relevant in today's times. Okay. And what should the student do with the knowledge that he or she has gained when you have taught them these concepts? Here in the project, they will apply those concepts. So when you read about these projects, they have a very extended learning that develops all the skills that we want. Okay, CBSE tells us 21st century skills. We all know 21st century skills. Which are those? Yeah, critical thinking, problem solving, communication, creativity, collaboration. Okay, all of those. So in the projects, you'll find that the student they have to apply and develop those skills. No problem, no problem, sir. Yeah. So here the learners have to think beyond and they have to apply what they have learned. It is just not replicating the same thing. So when you're giving me examples of the plant cell, the model of respiratory system, lungs, all of that is a replication which just adds on. Yeah, I'm not saying that those are bad ones, okay, but the level of skill development that happens with those are very minimal. You're just allowing them to kind of make decision about what will be the right material to use, or you're developing their fine motor skills, that how should they work with those materials and get them, an experience of how and where should those things be placed. But it is not extension of their thinking. These projects give them that opportunity and the detailed guidance you'll find in the teacher's resource. All right, so you don't have to worry about how should I do. In fact, what questions you will be asking your students is also given in the teacher's resource. So if you read through the projects, they are very very clearly stated and guided for you teachers so that you can achieve the outcome, which is everything: the application of the knowledge, development of skills, extended thinking, okay, and development of scientific temper and attitude. So go through the project and read next. These are just some examples of the projects that you'll find in the teacher's resource. And of course, the level of the project is always age appropriate. So it is not something that maybe that grade 3 child is not able to do and it is there. It is something that is relevant for that learner. Yeah, next. Yeah, I already told you in the beginning that in your books you have a section which is dedicated to development of the skills of scientific attitude, okay, and making them think and work like a scientist, because we want all the students to develop that exploratory streak of themselves, and do things like a scientist, do their own investigations, and come up with ways of recording, observing data, interpretation of data, identifying a pattern. Okay, all of that. Yes, next. Yeah, this is also something very interesting. I find it very, very interesting as a science teacher. Okay. All of us, how many of you already told me about models. How many of you have used models to teach a particular concept to the learners? Just show me your hands. How many of you are primary teachers who have used models? And the others? See, models may not be necessarily in today's world, in fact, in today's times rather. It can also be online, also, you have lot of 3D models. You know, you have a lot of sites which shows you the three-dimensional structure of any model or any, I would say, concept. Why do you think, as science teachers, we should use models in teaching? Not you. Anybody now? Very good to create interest in. Yes.
For better understanding.
Very good. For better understanding. What else? Encourage them.
Seeking attention, ma'am.
Seeking
For the
attention. Yes, absolutely. Again, it's a different way. Rather than just standing and talking, you're giving them that experience, that how does it look like. Anything else? Yes.
Explain about that topic.
Okay, you can elaborately explain about that topic. The most important reason, something.
They're doing, they know to come to know
The practical
practical
aspect.
acts.
Okay, okay. Very important reason. Better understanding. Okay, agreeing to all of that. The most important reason of using models is that, can I teach digestive system by taking them into somebody's digestive system? Can we do that? Can we take them on a trip to solar system and show them, oh, this is how solar system looks, see, let's go on a field trip there? Is it possible? So then what do? Use models. So whenever we have abstract concepts, okay, to which we cannot give any experience to them, we cannot take them into the lungs and show exactly how, the bronchus and the bronchi and the alveoli looks like. So we show them using a model so that they get a representation of how it is in reality. That is why we use models, to make the concepts clear. But why the concepts are not clear? Because you cannot make them see it, you cannot make them experience it. And that is why we use models, to clarify, okay, to give them a clear understanding of how it looks like in real life. But do you think there are any disadvantages of using models? You wait. Any disadvantages that you can think of that might confuse the learner or student, or might give, some kind of maybe tiny misunderstanding? Very good. So what do you mean when you say it's not the live one?
living things have a different cater when you look into than the non-living things. So I feel that the life inside it will not be shown.
Thank you. Thank you so much for that. Exactly. So when you're showing them the model, this also needs to be made very, very clear that this is a representation. It is not 100% accurate. Okay. It just helps you to understand better. Okay. And that is where the limitation of model comes. Different models have different, I would say, effectiveness. And that is why in the resources, it is not only that we talk about models and the usage of models, but we also go a step further, where we talked about the effectiveness of model. That means how effective that model is to understand that concepts. Okay, I'll just give you an example. I know I'm giving a lot of examples, but I don't know, I can't help it and just keep it inside me. Now, I was teaching them the same respiratory system, and uh, I think I showed them the balloon model of the lungs, very age old but very famous popular model, easy one to understand, the working of the diaphragm and the lungs and all of that, the inhalation exhalation part of it, the balloon model. Okay, I actually showed them, and it was, I think, during COVID times that we were all online, and I showed them that model. Okay, and so I taught them the respiratory system, then I showed them the model, and I then asked them a series of questions that, okay, how does this model help you in the understanding of the respiratory system or the inhalation exhalation? So they gave me a lot of answers. Yeah, it actually, when how the inhalation happens, so what happens to the diaphragm, and what happens to the lungs when you inhale. So we could see that in that model. So it made our understanding very clear. And so I said, how is this model useful to you? So it said, yeah, I mean, we could actually see how the lungs would be in our system, and how the bronchus is, and how the bronchi is. So it gives us it gives us a visual representation of how it might be inside our body. Okay, so they gave me all the positive answers, and then I told them, do you think it has some disadvantage of it, or is it creating some kind of misleading or miscommunication or misconception is getting arise in your mind because of that model? And then they started digging deeper. So they came up with the same thing, that it's not actually real. Okay, and in reality, in that model, you are pulling the diaphragm, but in the body we don't do that effort. So it's a wrong information, okay, that is being shown. So we are not kind of trying to critique the model negatively, but here we are developing the skill of analysis. You are giving that opportunity to the learner to analyze the model. Okay, not just accept everything on the face value. They should be able to question it, that no, this is something that is not absolutely correct. And because it was a grade 7 class, I told them, okay, so if I give you that opportunity, what all things would you change about this model? So it is not only about critiquing that model, okay, finding out what the limitations are, but again moving a step further. How many of you know Bloom's taxonomy? Bloom's taxonomy? Okay, fine. We'll go through that also. It's going to be your homework. Okay, this weekend you'll go home on Sunday and look at Bloom's taxonomy and understand that. Mandatory homework for all of you from my side. Okay, all right. So, yeah, where was I? Yeah, I asked them about how would you improve the model. So when you talk about improvisation, you're taking the thinking further. So you're not stopping at the knowledge and understanding that, okay, I've taught the concept of respiration. This is how the process of inhalation and exhalation is, and done. So when I'm doing that, I'm stopping only at the knowledge and understanding level, which is a very low level of cognition. But I took them to analysis, which is a higher order. Then I'm taking them to give me suggestions on improvisation, which is again similar to creating something new. Though I did not allow them to create, but they were thinking about what would they add if they would have to create it. This is the highest order of cognition, that is creating something new with a new idea, not the idea which is already existing. So they came up with that, okay, we can add sensors and make this model even more closer to the way it is in reality. So they were talking about different sensors, which I didn't understand because I don't know much about engineering and robotics. Okay, but I made them think that's the idea. And our students today, they go to so many STEM and robotics and all those classes, grade 7 and 8. So at least I allowed them to think, and that is what they came up with. So that is how you extend your learning. Now this thing did not take me like two lectures, it was in the same 35-minute class that I did. So it is not something that you have to think explicitly, do very, lot of effort taking and hard work. No, it's all just here. The way you think, you just need to alter that. Next. Yeah. So this is all about curriculum. As I told you, I'm giving you a 30-second pause to note down the new learning, anything that has stuck with you, any idea, okay? Anything that you want to note down. Think about the whole session. We talked about the curriculum of science. We talked about the four content strands, the skills, the importance of skills. We talked about thinking and working like a scientist. We talked about context. I gave you a lot of examples from my own teaching. So think about all of it. Take a deep breath, pause, and note it down or think about it. Assimilate that new knowledge. 30 seconds for quiet thinking. Okay? Time up, teachers. Any questions about the curriculum, the language that you'll see in the resources? See, I'm using these terms and the language you might find a little new. So you'll find these terms in your resources and your teacher's resource. You should be familiar with the terms, the lingo, the vocabulary of your resources that you'll be using. So any questions about science as a curriculum, the strands, anything at all, I'm open to it for another 30 seconds. Feel free to ask questions. Next. Gosia. Next. Okay. Yeah, yeah. Okay, in the morning we talked about teaching and learning approaches, right? What do you mean by teaching and learning approaches? In simple terms, I want simple. Okay, in your groups, what I want you all to just tell me, discuss it for maybe 30 seconds again. What do you exactly mean by teaching and learning approaches? What do you mean by it? 30 seconds. Your time starts now. Time up. Any responses from any group? What do you mean? Since morning, you all have been telling me about approaches. So what does it mean? Okay. Can we make it more simpler than that? Understanding and outcomes, that is what she said. Can we make it simpler? What does it mean to us as teachers? Teaching and learning approaches.
The effective way to convey the concept.
Very good. Effective way of conveying the concept. Okay, great. Anything else from this group? Any addition to that? Teaching and learning approaches is a two-way process. Very good. Anything? This group? Again, the same person is answering. Disqualified. This anybody else?
Connecting the teacher and the students.
Very good. Very good. A very good way of putting it up. Superb. What did you say? Yes. So approaches connects the teacher and the student. Lovely thought. Fabulous. Anything else? Shh. Okay. Sharing of knowledge and experience in simple way. In the most simplest words, teaching and learning approaches means for us as teachers how we teach. Okay, how do we teach in the classroom? To teach effectively, to connect the teacher and the student, we use a variety of approaches. That's all. Okay, so when I'm using visible thinking routines, that's one approach. When I'm using probably video based teaching, that's an approach. So when we talk about teaching and learning approaches or pedagogies in another word, it's simple as how do we exactly teach? Which are the different ways in which we can teach to make our teaching effective and engaging for our learners? And why should it be effective and engaging? Exactly, going back to the main thing, it should achieve our learning objectives. So everything revolves around the objective. All your planning, that is your approaches, your assessments, everything, your methodology, you will choose the appropriate methodology of teaching based on the learning objective. So these are again some approaches. You'll find these terms in the teacher's resource. These are again nothing but different ways in which we may want to teach. All right. So, active learning, it's all about what you have told me since morning. Active learning is nothing but you gave me the term in the morning, learner centered approach. Okay, so active learning is all about making your students involved in the process of learning. So if you have seen right from the morning, for everything I am making you do work. I am not giving you the answers, you are giving me the answers, and that is how all of us are learning. Okay, so that is active learning. All of you should be involved in learning, and that is how you build new knowledge on the existing one. So all of you are giving me responses based on your experience, your prior knowledge, and whatever you know about it. And then when we are getting so many other responses, you're building upon that knowledge. Okay, so you are responsible for your own learning in today's session. You know where you are, and it's upon you how much you learn. Okay, and that is how it is very, very individualistic in nature. But as a teacher, I know my objectives. I want all of you to understand the various teaching and learning approaches, the meaning of it. So that is the reason I am giving you examples, and I am making sure that okay, when you give me responses or when you work collaboratively, I get the evidence of your work, whether you have understood or not. Okay, and that is how, and that is what makes active learning very, very visible. Learning is visible because the evidence is there. You should have evidence other than your written tests. That is the evidence of achievement. It is not the evidence of learning. I gave you the example of my son. He's still achieving very good marks in maths. But if I tell him to stand and explain that why did you solve this sum in this particular way? Is there another better way? He will not even explain me. It is what the steps are. This is what I am supposed to follow. Why, what, don't question me. I'm getting you marks, no? That is the answer that I get even today. That is not what it should be. Okay, and I feel really bad because a child is so interested in maths, but he has no relevance or it is not taught in context. And we need to change that. CBSE wants us to change that. They should know why are they doing it. They should think and they should be able to explain what they are doing. That is what active learning is all about. You make them actively participate in their own learning process. Okay? Assessment for learning. How many of you know what is assessment for learning? Hands up. Assessment for learning. See, these are all terms, okay? Trust me, all of you would be using it and doing it in the classroom. But these are all new terms that you get. Okay? Sorry? Yes, knowledge of the student. So when I'm telling you to give me a thumbs up and thumbs down, that is one way of assessment of learning. I'm just telling you, okay, have you all understood? Do you have any questions about assessment for learning? You give me thumbs up. It's a very simple way. Okay, when I'm telling you to give me one responses, that is also assessment for learning. So I get to know, okay, this child knows a lot of things about it and this child is not knowing it. So I need to work with that child and see how can I help him or her. Okay, so apart from your regular testing paper and pen test, there are various ways in which we do assessment for learning. That is nothing but check for understanding during our regular teaching. So before moving ahead with the next concept or a smallest of thing, I need to know that okay, my learners have understood it and they can explain this concept to me very clearly and they can do a particular thing. Okay, differentiation. Differentiation is nothing but, as we know, how many of you know what is differentiation? Compare. Compare what? But in this context, what are we comparing? You wait.
Finding the individual needs.
Very good.
Finding the individual needs. Learners.
Very good. Excellent. Excellent. So yeah, in differentiation is nothing but as teachers, we need to know our students very well. Only then we can identify their individual needs. Okay, as I mentioned that okay, when I'm doing an AFL assessment for learning, I get to know okay, this child is very clear with the concept and this child needs something to be worked upon. Okay, so then I do a differentiation can be done in various ways. That's for another day that we can keep. Okay, but it can be done in very simple ways. It is not something that you have to really again take an extra effort. But if you have different grouping strategies in the classroom, okay, this child is very brilliant, I make a buddy system and they learn from each other. That's how they learn better also. That can be one way of differentiation. I help them with help words or cue words to answer or to help them respond. That is differentiation. Okay, I give them probably a differentiated task. Okay, I tell this person to write a paragraph, but I tell you that okay, you can draw also and you can use only words rather than writing a paragraph. That is differentiation. So differentiation is nothing but different ways in which we support the student so that all of them achieve the common objective. Okay, so you'll find lot of ideas in the teacher's resource for all of these. So active learning, various strategies, various activities you'll find in the teacher's resource. Assessment for learning ideas are there in the teacher's resource. Differentiation ideas are there. Okay, so in the teacher's resource there is lots and lots of things, but you cannot do it all. It's not possible. They've given you a lot of things, but as teachers, you have to be consciously aware about what you want to develop in that learner. Okay, what is your objective? And then pick and choose a particular activity or the strategy for any of these things. So, the most important thing is clarity here in the minds of the teachers. Language awareness is nothing but, as I mentioned earlier also, it is different ways of interaction. So when you're discussing what is happening, you're talking to each other. That is one way of interaction. Okay, I am talking to you, that's one way of interaction. You are talking to me is another way of interaction. Okay, you may be standing here and presenting to the whole group, that's again another way of interaction. So which modality of interaction you want at which point of time in your classroom, so that, remember the communication skills you all told me in the morning, we need to develop communication skills. Communication skills will be developed through all these different types of interactions that we should have in the classroom. Okay, it is not that one particular type is predominant. So you should have different ways and varieties of interactions in the classroom. Metacognition, we have been doing it. It's again another term for reflection. I've been giving you time for reflection. There are a lot of questions in your learner's book for students to develop the skill of reflection. As I told you earlier in the morning, they should be aware about their own learning process. Okay, where they are, what are they learning, how are they learning, what kind of help do they need to learn better, and what that learning means to them. How will they demonstrate their learning? All of those questions you'll find in the green arrow in the learner's book. That will allow them to reflect, but only if you give them time to do that. Otherwise, it is useless. A lot of teachers, they just skip those elements and they move ahead. Maybe you may not find time. So it is not necessary that you do it in all the chapters, but make it a point that you do it at a regular interval so that they develop the skill of thinking about their own learning. And skills for life, that we are doing it. Okay, right now, since morning in the session, all the skills that we talked about: collaboration, communication, creativity, problem solving, scientific thinking, all of those 21st century skills. Next. Yeah, next. So now we're going to look at all the next. Let all the all the components come. Now these are the components that you are using. Now this session is of very very important to you, very great importance to you. Okay, so you need to be aware about these components. So you are using the teacher's resource. Okay, the learner's book. The workbook is kept for your reference. Okay, and this is something extra that we don't have to worry. It's a separate paid resource. So we will be now understanding, okay, how all the pedagogies, the teaching and learning approaches that we talked about, we talked about think like a scientist, we talked about practical skills, how and where will you find those skills in your learner's book and teacher's resource, and how will the teacher's resource help you in planning. So we're going to do an activity. Go to the next one, please. So you have your extracts and the handouts. Just give me 1 minute. Yeah, give me this. Okay. Now, this can be a group task or an individual task. These are the printed resources that you have. Okay, the teacher's resource, the learner's book, the workbook, they're the printed resource. But the same thing is available on the digital platform, which is called as the Cambridge Go. They are the soft copies available. I'll just ask 1 minute. Guru sir, do we talk about Cambridge Go?
Have you all of you seen started using Cambridge Go, no, ma'am?
You are using? How many of you are using? Raise your hands. Okay. All of you have the login? How many of you don't have the login? Raise your hand to Cambridge Go. Don't have the login. Come on. Very good. 1, 2. Rest, all of you have the login. All right. Great. Whether you have or you don't have, you please get them. So they have it, right, Guru? So they are supposed to use it. Okay. Okay. This is the digital platform on which you'll find the soft copy of your teacher's resource, the soft copy of the learner's book, the soft copy of your workbook, and there are lots and lots of other resources. So there are lots of additional worksheets. Okay, there are lots of additional test papers. Then, something very, very important for teachers, there are answers to the questions to your learner's book and the workbook, and for all the worksheets and the additional test papers also. And trust me, you cannot give your answers without comparing it to what is given here, because it might happen that you have another perspective than what they have, because here everything is mapped to the objective, everything is in alignment to the teaching and learning approaches, to the objectives that are given. So please, before starting to plan, go and explore. It is very, very easy. It's very easy. And it will reduce your work and the time that you are taking out to plan your lessons and finding out worksheets on the net. Trust me, I have done all of this. So I know how much time it takes to browse and get a good worksheet for the learners. Again, when you get it from the net, it is not 100% aligned to what you're teaching. But we still give it because we don't find the apt ones. Here it is, everything is aligned to what is there in the learner's book. So you don't have to worry that anything is outside the syllabus. Okay, so please go and explore this Cambridge Go digital platform. It's going to be a boon for all of you. It will save your time. Plus, it will develop the skills and the objectives that we're sitting here and discussing. Next. Next. One very important, I would say, piece of advice. Okay. Please do not plan your lessons with only learner's book, because in the learner's book you'll not find all the information. Why is that? Exactly, thank you for that. Because it is learner's book. Are we the learners? Who is the learner? So the information that it has, it is relevant and it is pertaining to how much that learner should know or should be able to do. So the information there is not given for the teachers in any way. So you cannot plan anything with the help of learner's book. As teachers, you should know that, okay, this is what my learner is going to be doing or learning about or demonstrating. That idea you can get it from the learner's book. But how should you teach that concept? For that, you have to go to which book? Yes. For that, you have to go to the teacher's resource. So now we will understand what are the elements of the teacher's resource. So once you know what is there in the teacher's resource, it will help you to kind of make a very, very, I would say, conscious decision about whether you should be using it or not using it to plan your lessons and teach in the classroom. So for that, we're going to do an activity which is called as the scavenger hunt. Okay. Now, if you take your handouts, everyone go through the handouts and read the title Scavenger Hunt. Find the title Scavenger Hunt. Everyone found out? Thank you. All thumbs up if you found out. This is assessment for learning that I'm getting. The last group? Okay. The first group? I did not see your thumbs up. Did you get it? Okay. Okay. There are questions and there are titles. Now, from where will you find the answers to these questions? And there are somewhere around 36 questions in primary, and in lower secondary, I don't know. How many questions in lower secondary? 40. Okay, so it's not possible for us to do all of these now. It is up to you how you divide your task as a group. Okay, but your task is that for each heading you should be able to complete at least 2 questions. You should seek answers to 2 questions. Okay, and from where will you seek answers? You will seek answers, or you don't have to write answers on the basis of your thoughts and your imaginations and your experiences. The answers should come from the extract. So the first few pages, from page number 2 in the extract for primary till page number 11. For primary, it is from page number 2 to page number 11 that you'll find the answers to those questions. Okay, you can strategize in your group so that you finish the task in the time span of 15 minutes. You have only 15 minutes to complete the answers to all those 36 or 40 questions. So I would want you all to work smartly, strategize, divide your task, and you get it done in 15 minutes. Any questions regarding what you're supposed to do in the task? You can raise your hands if you have any questions. 15 minutes and at least 2 questions under each heading should be completed. Yeah, that's your sheet. Strategize, smart thinking and smart working. 5 more minutes. Teachers, 5 more minutes. See where you are, how much you have to do. Again, repeating, strategize, work smartly, group work. A minute to win it. Okay, a minute to win it. A minute left. Okay. All hands up. All hands up. Both hands. Both the hands up. High up. High up. Both hands up. Shake your hands. Shake your hands. Okay. Stop. Hands down. And pens down. Okay. How many of you, which group was able to complete all the question? Any group? Time's up, teachers. No more talking, no more discussions. Time's up. Acha, that group, you could finish all the questions. Huh? All the headings. Show. Really? Huh? But never mind. Each one did 2. So you could reach the last heading. Not, but yeah, somebody in your group, you could answer, no? Yes or no? Huh? Whoa. And which other group like that? Anybody else? You know what? I want all of you to stand up. Please stand up at your place. Please stand up. And all the others will clap for them. Please clap for them. Well done. You deserve this applause. Please sit down. Thank you so much. Okay, why do you think we should clap for them? Because exactly, I was giving you all clues that you have to work smartly to complete the task. It was an inevitable, it was an impossible task to finish within the time frame of 15 minutes. 40 questions was not possible by any individual. So I gave you all that hints. Work together, strategize. I was going on telling you all. So together we work and we make things work if we work together. Okay? So this is what you need to inculcate in your students. This is what collaboration that we are talking about. We're only talking. But we are so self-involved in doing everything. We cannot do everything. We need to build this team spirit. So whenever you give them a task, sometimes you need to give such impossible tasks and allow them to come up with strategies. So the importance is not about completion of the task, but the main idea is how do you work around it to get it completed. Okay? And that is the reason I appreciate them for that. So they could finish the task, they could strategize it, they could do it without any stress. Can you imagine the amount of stress that you all had? You were trying to finish. They had only 2 or 3 questions individually to finish. Look at the stress level and imagine your stress levels. Today's world is about smart work, teachers. Smart work. Okay? That goes beyond hard work. So hard work is always going to be there and it will be there. But smart work is also required. So well done for that. So please rethink, your ideas about how to get work done with your students. And your students would love to collaborate and work together. Because they're children. They like to work with each other. Because all of them are their friends, and you build that very, very healthy, friendly spirit, that warmth in the class. To make use of that. So you should have group work like this. Sometimes you can have paired work. Sometimes you may have individual work. Okay? Have a mix of all of that. Okay, let's go on with discussing and understanding how much have you understood the teacher's resource, because as I said, the discussion is going to be based on how the teacher's resource is a very useful resource that will help you in planning your lessons. Okay, right. So I want all of you to look at your extract. Okay, and we will be discussing the headings of it, because you have to use this book for your planning. All of you have a lesson plan document or something, right? So this will help you to do that task. So the first element of every, if you see your teacher's resource, the name of the chapter is exactly the same as it is written in the learner's book. So the name of the unit, the name of the topic, everything is exactly the same as you'll find in your learner's book. Okay, so every unit is divided into topics. If you see, the first element is the unit plan. So this unit plan, it gives you an idea about, if you have read the questions in unit plan in your handouts, what are the questions that they've asked you? How many topics? In which topic is the water cycle? How long will you teach that topic? How many lessons? Yes. How many worksheets? So where do you think this information will help you? In the lesson plan, if you have a document, do you think this information will help you? Where will it help? Yes, what about chapters? You're right. What about chapters? It helps you in, yes, so it will help you in planning the term. Okay, so you get to know that, okay, approximately I need to have so much time for this unit, and in my term 1 I have so much time, so I can fit in these many chapters there. So in your initial term plan, term wise plan that you do, maybe first, if you have 3 terms, then in term 1, term 2, term 3, if you have 2 terms in term 1 and term 2, it will help you in that initial planning. So if you're using this book for the first time, okay, how will you know that, okay, chapter 2 will need more time than chapter 3? So when you look at the unit plan, it gives you a rough estimation. Okay, this is a rough estimation, it is not exact or accurate. It is a rough estimation to guide you to plan that, okay, if I'm keeping 4 periods for chapter 1, I need to keep probably 6 for chapter 2 and maybe 8 for chapter 3. So next time or next year, when you have already taught, you can then make a change based on your experience. But this helps you when you're doing it for the first time. So that information is there, which will help you to bifurcate your chapters. Okay, where you want to place them, in which term. Second thing it helps you with is the learning content. What do you think is the learning content in the unit plan? In the table. Exactly. So it's not exactly the learning objective, but what will you teach in that topic? For example, in dissolving, I will be talking as a teacher. I should know that what is the broader content that I'm covering in that topic. So probably in dissolving, I have solutions and use of vocabulary and property of solution is something that I will be focusing on. So as a teacher, I have an idea that, okay, this is what I will cover in that topic. So it gives you the rough idea of the content that you will teach in that topic. Then you have resources. Okay, so if I'm you teaching the topic of dissolving, for primary it is going to be different. I'm using lower secondary science. Okay, so primary teachers can look at what they've given you for your topic. So for resources, so questions 1 to 5 deals with the topic of dissolving. So you can guide your learners that, okay, we have learned about dissolving, so these 5 questions you have to keep in mind the topic of dissolving that we've understood, so that the learners will not have any wrong idea, or they will not give any wrong answers with regards to other concepts that you've taught. So it gives you a very clear guidance with respect to which questions in the learner's book are aligned to that topic. Okay, then they also talk about think like the scientist. I told you in the learner's book you have think like a scientist. So which investigation is dealing with the topic of dissolving? So which skills are you developing, and how will you bring about the scientific approach in teaching dissolving? That is mapped here. Workbook exercises mapped. Okay, that workbook 2.a. If you want to give worksheet for dissolving, so you'll go to exercise 2.1 and take questions from there to check their understanding or put it in the test. So you know that they're aligned to what you have taught in the class. Yeah, and teachers resource worksheets. So these are additional worksheets, as I told you, on Cambridge Go. Template 2.1, again additional worksheet. Peer assessment for activity. So all the resources are aligned so that you have a clear idea and you keep these resources ready when you're teaching that topic. So when you're planning, okay, you will incorporate all of these or some of these as per your needs and requirements and your time schedule. That okay, I will incorporate these things from the teacher's resource, from the learner's book, and these activities from the workbook, so that I can have a full lesson. So this gives you an outline of every topic and every resource that is aligned to that topic. That is what learning plan is all about. Next, is that thing very clear about what unit plan is and how does it help you? Okay, so it gives you a very broad outline of each and every chapter and how many units are there in that chapter, what resources are aligned to that topic, what questions from the learner's book, workbook, and the teacher's resource, what additional worksheets, what all things are aligned to that chapter, so that you plan it accordingly. Okay, then you have cross unit resources. Wherever it is applicable, it will be not there in every table of unit plan. So wherever it is applicable, you'll find check your progress. If there is a project aligned to that chapter, that will be mentioned, because the project will not only be related to science, but it may have some elements of numbers or data or from maths, from English, from geography. So the project will also have cross curricular integration. Okay, so all that is mentioned in the teacher's resource. So cross unit resources are also told to you. There's also an additional component, language development in science. That is an additional paid resource. So you may not have so the part which tells language development worksheets, you may just want to ignore that because you don't have it. Then we have background knowledge. Now what is background knowledge? What will you do with the background knowledge given in the whose prior knowledge? But this is given in the teacher's resource, and teacher's resource is for teachers. So what will you do? What is given here, and what will you do with that? Okay. Eggs. Okay. Okay. Yeah. Somebody said teacher, student, something, something. I could hear only teacher and student. Yeah. Background knowledge gives you a complete overview of what is there in that chapter or that unit. Okay, it also gives you certain information. Now you are using it for the first time, so next year you're using it this year, then next year when you use it again, your students would have used this book. So this will also give you an information that okay, this student the students of this grade have covered this part of the chapter in probably some previous grade. So you know that okay, I have taught them, or the students already know this. So that is your starting point of planning, that you'll check your prior assessment question, or you'll set your prior assessment or pre-assessment questions on that. So it gives you idea as a teacher what you have to teach in that content. Okay, how much you have to teach. It will also tell you wherever applicable that you are not supposed to teach this. Okay, they will tell you that. So that very clear boundaries are set in the background knowledge. And also it gives you an information about what the learners have already learned in some prior grade and what is important for the next grade. So that background information is very important for you to know as teachers. If you're new to teaching science, suppose, okay, you don't know what to teach and how much to teach, because as teachers we feel like giving everything to the learners. So we go beyond. In grade 2, we will talk about what they need to know in grade 8. Okay, so we need to confine ourselves to what is required at that grade level. So all that information is given to you in the background knowledge. Okay, it is for the teachers planning and understanding of that topic. That is what background knowledge is all about. Then we have something which is called as teaching skill focus. Teaching skill focus, any ideas? What is it all about? What questions you have answered on that? What information does it give you? What are the skills? So the skills is for who? Okay. Whose skill development is happening? Learners, to make meaning of what they are reading. Okay. Okay. So in one thing, but what I am holding is, it is saying plenary is one. Plenaries are a good tool that can be used to ensure you have an overview of learner's progress and understanding during the lesson, and can be used to inform you what your next steps are. So they're not the same. Teaching skill focus. Is it same? Oh, yes or no? What? What is the answer? Teaching skill focus is same for everyone. For primary, what is there? For primary, what is the teaching skill focus? Reading for framing, no, reading for meaning in science. Learners need reading skills to understand scientific concepts. Okay, so it is more about the vocabulary and the usage of scientific terms and what it means in science. Here it is about plenaries. So are they same? They are not. Okay, so teaching skill focus are nothing but your ways. Again, it comes under your teaching and learning approaches, or in simple terms, it comes under strategies that you would want to learn more to make your teaching very, very interesting for your learners. So teaching skill focus talks about a bit more or more strategies that you can learn as teachers and apply it in your classrooms. So every chapter will have different teaching skill focus. So it is a strategy that I am learning new as a teacher, and I can apply this to not only this chapter or this topic, I can apply this to any subject that I teach and to any topic and any chapter. So it is kind of learning new ourselves as teachers. You're learning something new, some new ways of teaching. Okay, it's nothing but new pedagogies, new strategies to teach in the class. It's a way of developing your own teaching practice. It has nothing to do with your lesson planning. It has nothing to do with that topic only. It is your own self development that is happening when you read and understand and you know more, so you'll have more strategies to pick from. Okay, so you're developing your own teaching practices, and they have given you very, very relevant example of how will you do it, what should you do, how should you conduct that strategy in your classroom. And then it should trigger, okay, I can apply this to this topic also, I can apply this to that topic also. Okay, so you become more aware about different ways of teaching. That is teaching skill focus. Yeah. Then you have learning plan. Okay, we talked about visible learning. We also talked about evidence. So if you read your learning plan, you don't have to worry about the first column, that is learning objectives. Okay, just cross that out, it's not for you. But you can start with learning intentions and success criteria. So learning intentions are again nothing but what are you intending that the learner should learn. So they are framed for you as teachers, and you know that what are you teaching exactly. And what is success criteria? If you read them, exactly, it is learning outcomes, and it goes a little beyond because it helps you as teachers. So when you or when we discussed assessment for learning, remember? Okay, if you read, I need my specs to read. Yeah. So here for a low secondary, the learning intention is separate dissolved substances by using chromatography, and the success criteria is describe how to carry out a practical task. So the learner should be able to describe how to carry out a practical task. Only then the learner is able to demonstrate that he has understood how he will separate dissolved substances. So it is the evidence of what the learner will do to show that he has achieved the learning objective. Okay, that is success criteria. Simple example can be, if I'm talking about the learning intention is explain the process of photosynthesis. Okay, and I am designing my success criteria as for probably grade 3 student. I'm just wanting them that they should be able to define the process of photosynthesis, and they should be able to list the raw products, the raw materials and the products of photosynthesis. My success criteria will stop there at grade 3 level. Now when I'm teaching the same topic in grade 7 or 8, explain the process of photosynthesis, I will now design my success criteria as the learner should be able to explain or write down the steps of photosynthesis. The learner should be able to define the process of photosynthesis using the key scientific terms, and the learner should be able to write chemically balanced equation of photosynthesis. Are you understanding how my success criteria changed based on what objective I want to achieve when I'm teaching photosynthesis? So the learner should be able to do all of these three things. Only then I will understand or get an idea that, okay, the learner knows or has achieved the objective. Any doubts about success criteria? You'll have to do so, but I gave you an example of how I would design it, but here it is already done for you. So you don't have to design it. It is already done for you in the teacher's resource. Language support is all about scientific key terms and their meanings. Okay. Then we have common misconceptions. We'll just park that there. We'll move on to the starter ideas, main teaching ideas. So if you see the starter ideas, it is linked to getting started in your learner's book. So in the learner's book, you have a title which is called as, once you start a new chapter or go to the new chapter in your learner's book, that is your textbook, it is written as getting started, and then it gives whatever the learner is supposed to do, maybe answer a few questions or see what is there in the image. Okay, but in the teacher's resource, it tells you what you have to do as a teacher when the learner is answering those questions. What is your role? Okay, so the starter idea is linked to the getting started activity in the learner's book. It gives you a very clear picture about what is the task and what you are supposed to do, or how will you instruct the learners with respect to that task. Then you have the main teaching ideas. Again, there'll be more than one starter ideas. So you can use the starter idea from the learner's book. And if you want to have more than one, you can use it from the teacher's resource. It's up to you. So when you look at it, main teaching ideas, you will have the learning intention, which you had it in the learning plan. So that's the reason I said we're always more inclined towards making our classroom activity based classroom. Okay, but our activities should not be activities only, but it should be objective led activities. And this helps you with that, because every activity in the main teaching idea, it has the learning intention written for you. It is mentioned for your guidance. So you know what objective will you achieve when you carry out this activity. So the resources are mentioned so that you can plan out everything, get things ready. The approximate time is given to you. There are guided questions, okay, given for you so that you can guide your learners when they're doing that activity. Okay, and how will you do assessment for learning, that is also given to you. Differentiation ideas are given to you, that if you want to carry out differentiation, meet the requirements of the learners, what differentiation ideas you can do in that task. So everything is given to you for that particular activity, and that is why it becomes purposeful and meaningful, and just not that your learners are engaged without a meaning or a purpose. They don't know why they are doing that activity. Okay, so the clarity is there from the teachers end, and then you can give the same clarity to your learners, because the intention is mentioned here, and the success criteria is already mentioned in your learning plan. Okay, so that is all about your main teaching ideas. Then the practical approach, if you see, the think like the scientist. So for that also, for everything like the scientist in your learner's book, there you'll not find the learning intention or what skills are being developed. Okay, all that details you'll find in the teacher's resource. For every think like the scientist activity in your learner's book or your textbook, all details with respect to the objectives, the resources required, how will you guide the learners when they're doing that practical task, what safety, very, very important. We never talk about it. Safety is the first thing that you should be talking about for every investigation, what they should be careful about. Okay, then description about how will you carry out that activity, practical guidance, everything is given here. So please read and then choose the activities from the teacher's book. Again, differentiation ideas, questions, plenary idea. Plenary is how will you conclude that topic. Okay, those are plenary ideas. How will you conclude? Again, those are just not simple question and answers. So there are many, many activities given for plenaries also. Okay, so here I can see one, that cards with terms applying to the topic, as in the activity is given. Using the correct words, template 2.4b, terms and definitions could be used. So this is an activity that you're using it for the closure and check for understanding. Mastermind is an activity that you're using. So there are variety of activities that are given for everything, for starter, for your main building up of the lesson or the concept, and for closure. Variety of strategies and activities are given. Homework ideas are also given. Apart from the workbook, there are variety of homework ideas which are very, very creative homework ideas, and just not your question and answers all the time. Lot of ideas, creative ideas are given. Project guidance, if I would have had time, I would have really told you to read the project guidance here itself. Those are just amazing. The amount of clarity that it will give you as teachers will help you to guide your students better. Okay, so project ideas along with detailed guidance is given, and you'll find the similar layout for each and every topic or each and every chapter. Each element will remain the same. So that is all about teachers resource and what each heading means. Any questions, or if you've not understood any header or any title and what it contains and how it will help you, you can ask me regarding the teachers resource. Any questions? I know we are running late. We are 15 minutes late for lunch. Any questions? Should we move on? Sure? No questions? Once you'll start using it, you may have questions. So at that point of time, note down your questions. Don't just let it go. So as and when you start using it, anything that comes to your mind, you've not understood this, what to do with this part of the information, note down your questions. Follow it up with your heads. Your head will follow it up with the Cambridge representative, and you'll get your answers. All right. I think that's the end of the teacher's resource. When we come back from break, we will talk about misconception that we have left out here. Okay, and we'll talk about the learner's book, and then we'll do the experiment. So these are the elements that are pending, and we take it up when we come back from break. It's 1:45, and so 1:15 will come back. Sorry, 2:15. Sorry. Is that good enough time for you all to have your lunch? Okay. So please be on time. That's a request so that I can start on time and we finish on time. Thank you so much, teachers. Thank you.